Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Researchers at the California Institute of Technology have long been ambitiously motivated to bring optical fiber-like loss onto a silicon chip, and now their work is paying off. The team has designed an approach to translate the spool-based fabrication of optical fiber and guide light on silicon wafers, which results in ultra-low signal loss that's comparable to that of optical fiber at visible wavelengths. The new method brings germanium-doped silica, the core material system of optical fiber, into planar integrated photonics using a fully CMOS foundry-compatible process. Essentially, the team was able to adapt that material to create waveguides. The approach overcomes several long-standing challenges, including short wavelength scattering loss. The team says that at visible wavelengths, Rayleigh scattering typically dominates, but their furnace reflow process enables atomic scale smoothness that suppresses the limitation. Key advantages include record low visible band loss and broadband operation as high as 1550 nanometers. The team says this work narrows a decades-old performance gap between optical fiber and integrated photonics, and could fundamentally reshape applications like portable optical clocks and high-power chip lasers. Ayar Labs, a co-packaged optics manufacturer, has appointed a new vice president of engineering. Sankara Venkateshwaran joins the California-based company with more than 2 decades of experience with mobile, computing, networking, and infrastructure silicon products. He has held engineering and leadership roles at companies including Atheros, Qualcomm, and more recently Intel, where he served as Vice President of Foundational Networking Silicon Engineering. Ayar Labs representatives say the move will allow the advancement of the company's co-packaged optics development and deployment to meet the scaling demands of AI infrastructure. A strategic acquisition is in the works at high-performance laser and combiner designer Oxxius. The San Francisco-based company is purchasing 89 North, a developer of advanced laser-based illumination and imaging systems. Representatives of Oxxius say the acquisition will see 89 North's high-power diode laser illuminators significantly strengthen their presence, particularly in microscopy markets, and ultimately enhance innovation capabilities. All-optical physiology has long had the potential to manipulate neuronal circuits in vivo and examine functional circuits within single fields of view. But there hasn't been a way to explore the functional columns that are critical to understanding neocortical processing, until now. Researchers at Tsinghua University in China have developed a new approach called cross-layer all-optical physiology, a novel tool that enhances that understanding by achieving high-speed, cross-layer two-photon imaging and optogenetics. In their work, the team uses functional markers, namely a genetically encoded calcium indicator, to monitor neuronal activities in vivo based on their fluorescence signals. Opsons are also part of the process, allowing manipulation of that activity based on optogenetics. The new cross-layer approach makes possible the dissection of neuronal circuits within functional columns in vivo and the observation of those columns' physical structure to better understand how it all works in real time. The team says this method could become an essential tool for directly probing functional connectivity and fundamental interactions within neuronal circuits. The platform could also be broadly applicable to examining neuronal circuits involved in brain disorders and neurological diseases. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.